Today we're just going to do a brief review of right triangle trigonometry. So this is the trig that you learned in geometry, and we are going to review both the special right triangles, which are your 45, 45, 90, and 30, 60, 90, as well as how we can use sine, cosine, tangent to solve for missing sides in a triangle. So this trigonometry is actually not what is in our book in Algebra 2. Algebra 2 has the next level of trig, really focused on what we'll call the unit circle, as well as graphing the basic trig functions. However, in order to build the unit circle and in order to understand the graphs, we have to know the trig that you learned in geometry. Another reason why this right triangle trig is so important, other than it's the foundation prerequisite for the trig we're going to talk about, but you always see these type of trig problems on the ACT as well, so very important stuff to know. Okay, so when we look at these two theorems that you learned in geometry, the 45, 45, 90 triangle theorem says that if you have a 45, 45, 90 triangle, then the hypotenuse has to be radical 2 times as long as each leg. So that is telling us, if we were to write it in formula form, that hypotenuse equals leg times radical 2. The reason why I like to look at it as a formula is because then we understand that we don't always have to be given the leg to solve the triangle. So whichever side you're given, you can plug it into the formula and solve for the other variable. So we're going to look at an example, and if you look down at your worksheet, you'll see everything in number 1 is a 45, 45, 90 triangle. This one's a square, but remember the diagonal of a square forms two 45, 45, 90s. So here, and I forgot to label my legs here. There we go. So on this example, we want to find both x and y. We know that this is a 45, 45, 90 triangle because these two sides are marked congruent and this is marked a right angle. Because we know that triangles have to add to 180, which means if 90 is taken up, there's 90 remaining. And since they have to be the same, because the sides are the same, 90 divided by 2 gives us 45. So we are certain that that's a 45, 45, 90, which means we can use this formula. So now we just have to decide which side we're given and which side we're looking for. So in this case, it doesn't matter whether we solve for y or whether we solve for x first, because we're using the same formula regardless. But it does matter which side the 24 goes in for. So in this case, the 24 is across from the right angle, which means that it's the hypotenuse. So in my formula, I'm going to put the 24 in where the hypotenuse was. So 24 equals leg, which I could put in either x or y, times radical 2. And now I just need to solve for x. So I'm going to get it by itself by dividing both sides by radical 2. So those will cancel and x is alone. However, I'm not done because it's not in simplest radical form. It's in radical form, but it's not in simplest radical form. So next thing I need to do then, like we reviewed earlier this year, is to simplify by rationalizing the denominator. So I'm going to multiply top and bottom by radical 2. So on the top, that gives me 24 times radical 2, which is just 24 radical 2. And on the bottom, any radical times itself, remember, is that same number but without the radical symbol. So radical 2 times radical 2 is a plain 2. Last step then, we can simplify because the 24 and the 2 can reduce. So that gives me 12 radical 2. Notice I did not simplify the radical. You cannot reduce radicals with plain numbers. We only reduce radicals with other radicals, plain numbers with other plain numbers. So in this case, our x is going to be 12 radical 2. Now, if I go to solve for y, I really don't need to do any additional work. X and y are marked congruent, so I know that they're the same. They're both going to be 12 radical 2. Do not, under any circumstances, try to turn in this paper to me with decimals here. No decimals. We are putting these in simplest radical form. That's really what we'll be doing in all of our trig unit. We're going to review the Sohcahtoa here, but there's not a lot that we'll use decimals for other than the real life situations. All right, so now let's take a look at 30, 60, 90 triangles. So 30, 60, 90 triangles have two formulas because there's two parts of the sentence here. First thing we know is that in a 30, 60, 90 triangle, the hypotenuse is twice as long as the shorter leg. So hypotenuse equals short leg times 2, twice. Okay, great. So we've got that. Then it says the longer leg is radical 3 times as long as the shorter leg. So long leg equals short leg times radical 3. Now, unlike with a 45, 45, 90, it matters which formula I use in some cases because it depends. What am I looking for and what do I know? If you know the short leg, you could start with either formula because short leg appears in both of them. However, if you only know the hypotenuse or only know the long leg, that forces you to start in that formula to solve first. So if we look at our example 2 here, the 30-degree angle is here, which means that I know this one is the 60-degree angle. One of the things that you learned in geometry was that in a triangle, the shortest side has to be across from the smallest angle, the longest side has to be across from the biggest angle, and so on. So I know that in this triangle, whatever is across from the 30-degree is going to be my short leg. So if I go across, that's going to be x. So x is my short leg. My hypotenuse is across from the 90, so that's my y, which means that the 12 that I'm given is the long leg because it's across from the medium-sized angle, the 60 degrees. So it's longer than the short leg, but not as long as the hypotenuse. So that means that when I go to solve for x and y here, I'm given the long leg, so I have to start with this formula here. So I'm going to take long leg, which is 12, equals short leg, which is the x, times radical 3. So this setup looks extremely similar to what we had here. In order to get my variable alone, I have to first divide by my radical. And just like in example 1, these are going to cancel, but here I'm going to have to rationalize. So multiply by radical 3 on top and bottom, which is going to give me 12 radical 3 on the top, 3 on the bottom, which then the 12 and the 3 will reduce. And so I now know that x is 4 radical 3. Now I'm not finished, and like in example 1, I can't just put equals y. Here, x and y are not the same length. It's not an isosceles triangle with the legs that we're talking about. So I now need to go back and to solve for y. So we already said that y is the hypotenuse. So that means I have to use this formula to find it. So hypotenuse is y equals short leg times 2. Well, the short leg was x, so that's what I just solved for. So 4 radical 3 times 2 is going to give me y. Remember that just like we don't reduce radicals with plain numbers, you don't multiply radicals times plain numbers. Plain number times plain number, 4 times 2 is 8, and then radicals times other radicals, which in this case there's only 1, so it stays. So now we know that the value of y is 8 radical 3. Now, example 2 are going to be your 30, 60, 90s. Remember, it's not always going to be set up exactly like this one. If I give you the short leg, then you're doing something different than what you do if I give you the long leg. But the point is, find the formula that you need and solve for the other variable. All right, the last example that we're going to do here is on Sohcahtoa. So in case you've forgotten, which I really hope you haven't, Sohcahtoa tells you which trig functions are formed from which sides in relationship to an angle in a right triangle. So SCT stand for sine, cosine, tangent. O stands for opposite, H stands for hypotenuse, A stands for adjacent. So this Sohcahtoa acronym tells you that sine is formed by taking the ratio of the opposite side to the hypotenuse. Cosine is formed by taking the ratio of the adjacent side to the hypotenuse. And the tangent is formed by taking the ratio of the opposite side to the adjacent side. Remember that opposite and adjacent are relative. They are relative to the angle that you are given. So in this case, I am given this 36-degree angle. In relationship to that angle, the side that is opposite it, which means across, is going to be the 6. The adjacent side is the one next to it that's not the hypotenuse, so that would be the x. And then the hypotenuse doesn't change, it's always the one that's across from the right angle. So in this case, y is my hypotenuse. So that's really important because we have to be able to decide which trig function we're going to use. So it doesn't matter whether you solve for x or y first. I usually solve for x first just because that's alphabetical order, but it does not matter. You could solve for y first if you wanted. So what we're going to do is we're going to look at the x and we're going to say, okay, that's the adjacent side. Then you need to look for the side that you know, which in this case is the opposite side. So the ratio that uses both the opposite side and the adjacent side is the tangent, which means that to solve for x, I'm going to have to use the tangent. So we set it up, tangent of the angle, just 36 degrees, equals opposite, because tangent says opposite over adjacent, opposite, which is 6, over adjacent, which is x. And so I'm going to solve this now for x. So in order to solve for x, that means first thing I need to do is get that x off of the bottom. So I'm going to multiply both sides by x. So you have x times the tangent of 36 is equal to 6. And again, my objective is to get x alone. So the next thing I would do then is to divide by the tangent of 36. So these are going to cancel, and that will get x alone. Now these are the ones like number 3 on this worksheet where you're going to round to the nearest hundredth. And we're going to have to use our calculator. No one knows the tangent of angles like this just off the top of their head. So I'm going to pull up my graphing calculator here. And what you don't want to do is you don't want to round in the middle. So you don't want to do the tangent of 36 and then divide by a rounded answer. What you want to do is type this whole thing in, 6 divided by the tangent of 36. So first thing that you need to do on this graphing calculator is check the mode, because if your graphing calculator is brand new, its mode probably defaults to radian here, which when we are doing right triangle trig, we need it to be in degree mode. So press mode, and then if it is indeed in radian mode because the radian is darkened, scroll down and right, and then press enter on top of degree. Now, we will have to be changing back and forth between radian mode and degree mode in this unit, and you have to make sure that you know when to be in which mode. So in this case, we're going to switch over to degree mode, so then I can press second quit. If it's not in degree mode, you are not going to get the right answer, and you're going to be very confused as to why when I read you the answers for your homework. So what we're going to do here is, now that it's in the right mode, we're going to do 6 divided by, and now I need to use parentheses here because I'm doing the tangent of 36. So 6 divided by tangent of 36 degrees. And then I can press enter. And I have my solution here. The directions on this worksheet tell you to round to the nearest hundredth. So hundredths place is the second decimal place. So since the third one's an 8, we're going to round it up. So we're going to say that x is approximately 8.26. So go back over here, x, and remember these squiggly equals mean approximately, so that tells whoever's looking at your answer that it is rounded. So 8.26. Okay, and so now that we've solved for x, the last thing that we need to do is to solve for y. So we're basically starting over when we're solving for y here. It's a completely new problem. So just like we did for x, what we want to do is we want to look at which side y is in relationship to the angle that we're given. So in this case, we already labeled it, y is the hypotenuse. Then we look at the side that we already know. Here's the key. You do not want to use a rounded value to solve for a different variable. We don't have to. So please do not use what you solved for here because that's rounded. In this problem, we used our 4 radical 3. Number 1, because we didn't have a choice. But number 2, this is an exact answer. This isn't. If you use rounded values, it can cause your answer to be just a little bit off, which means that it might not be accurate to the nearest hundredth place. So please don't use the x to find the y. Use the 6 that we already know and we have an exact value for. So in relationship to the 36, the 6 is the opposite side, and the variable that we're looking for is the hypotenuse. So when I look at this acronym here, the one that has opposite and hypotenuse is this one, so sine. So I'm going to set this up as the sine of 36 degrees equals, opposite goes on top, so 6 over hypotenuse, which is y. Now you'll notice that this is set up exactly like the one where we solved for x. And the one where I solved for x here, you can see I multiplied by the x first and then I divided by the tangent of 36. But what ended up happening is that the tangent of 36 and the x switched places. So if you can remember that, it's totally fine with me if you skip, this whole showing to multiply and divide, because that's always going to be true when it's this setup, is that the variable from the bottom and this over on the left side are going to switch places. So that means that y is going to equal 6 divided by the sine of 36. And so then, just like we did when we solved for x, I'm going to go to my graphing calculator and I'm going to type in 6 divided by, and then I'm going to type in this time the sine of 36. Press enter, and I've got 10.21 if I'm rounding to the nearest hundredths place. So y is approximately equal to 10.21. So I've got my x, I've got my y, which means that the triangle is now solved for its 2 variables. And so these ones are going to be like number 3. So on all three of these letters that are part of number 3, you're going to use sine, cosine, or tangent. So in this example, we didn't have to use cosine, but we use cosine when the side we're given or looking for is the adjacent, and the other one is the hypotenuse. I do just want to show you one last thing real quick, and that is that to illustrate that if you have your calculator in radian mode, so see right here now it's in radian mode, so I switched it back. If you have your calculator in radian mode, you will not get the same answer. So if I do 6 divided by the sine of 36, and it's in radian mode, and I press enter, look, I get a negative answer, which obviously doesn't make sense. I can't have a negative side length. So please, 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 if we're using degree angle measures, you need to make sure that your calculator is in degree mode. All right, so that is it for the examples. So your job then is to finish the rest of this worksheet here for the right triangle trig.